Hello students, welcome back to my YouTube channel Maths and Matrix, and in this video I am going to discuss further 10 questions from the paper NDA 1 2018 Mathematics and the paper set A. Alright, so let's continue with these 10 more questions beginning with 101 question of this video. In a binomial distribution, the mean is given to be 3 times its variance. You know, in binomial distribution, we write the mean is equals to NP, and this is given to be 3 times the variance, which is NPQ in case of binomial distribution. See students, you should know the formulas of binomial distribution. How do you find the probability of x is equals to r successes, and you should know what is the formula for calculating mean of binomial distribution and variance of binomial distribution. Like here I wrote the mean formula is NP and variance formula is NPQ. In this problem they said mean is 3 times its variance. If this is known to you, you have to determine the probability for 3 successes out of 5 trials. Means n is equals to 5 you will take and r is equals to 3 you will take to determine the probability at x is equals to 3. Alright, so for that you need to here determine what is P and Q. So in this 1 by 3 is equals to Q, and that simultaneously gives you the value of P, which you know 1 minus Q, so that would be 2 by 3. So P and Q are known to us now. Let us quickly calculate P at x is equals to 3 by formula NCR P power R Q power n minus R. Here R value is 3, okay. So n value is 5, so 5C3 P, which is 2 by 3 to the power 3 into 1 by 3, which is the value of Q, to the power 5 minus 3, which will be 2. Now you know that this 5C3 is same as 5C2, and how do you calculate 5C2? 5C2 you will calculate it by 5 into 4 by 2 into 1, and 2 by 3 the whole cube is 8 by 27, whereas 1 by 3 the square is 1 by 9. So you can see that this becomes 5 to the 10, 10 into 8, 80 in the numerator, and that is in the option A. But you also check the denominator, 27 into 9, which is 243. So the right answer to this particular question is option A only. Alright, coming on to the next question, 102. Here we have given 3 statements to check which amongst them are correct statements. First one, if you see, it's a basic formula step. Probability of 2 events, union of 2 events, which is probability of first event plus probability of second event minus probability of intersection between them two. So this is your A complement first event, B is second event, just a formula of probability of A union B here. Whatever here A complement, same carried in the formula. So the first formula is clearly the correct formula. So statement 1 is correct. And now the statement 2, if you see, probability of A intersection B complement. You know what does it mean? This is same to say that probability of A minus A intersection B event. So it is basically becomes probability of A minus probability of A intersection B. But they gave us probability of B minus probability of A intersection B, which is wrong statement. And what about the third statement? In that there is a conditional probability formula. You know that probability of A by B is probability of A intersection B upon probability of B, which gives us this particular formula by transposing the terms, like P of B, if you send it in the LHS, it becomes the RHS of the third statement, isn't it so? So third statement is correct, first statement is correct. So which are correct out of these 3? They are like 1 and 3 only. So option B is the right choice. Alright, coming on to the next question, 103. Here you see that this is a question on regression analysis where you know correlation coefficient R. The value of R is given for the variables x and y, that is the correlation coefficient between x and y is given 0.6, and covariance is 27, variance of y is 25, then you are asked to find variance of x. See, these kinds of questions are purely formula based. You need to remember correlation coefficient between x and y denoted by Rxy, it is equals to covariance between the variables divided by root over variance of x into variance of y. So if we now substitute the values, Rxy value is 0.6 into covariance is 27 divided by root over variance of x is unknown into variance of y is 25. So we can see that root over 25 is 5, which will get multiplied to 0.6 in the LHS, and 0.6 into 5 equal to, we have 27 divided by root over variance of x. So if you handle this, you're going to get, this is 3, right? 3, 1, 3, 9. So root over variance x is equals to 9. On squaring both sides, variance of x becomes 81. And that's the answer, option D for this question. Alright, coming on to the next question, 104. The probability is that a student will solve question A and question B, respectively 0.4, 0.5. So what is the probability that the student solve at least one of the two questions? See, there are two questions, A and B. And here student is intended to solve at least one, means he can solve either A or B or both. So the question is about finding probability of A union B here, which is equals to probability of A plus probability of B minus probability of A intersection B by formula. But here, what is the probability of A intersection B? That is to be understood here. A and B are the events of solving question A and question B respectively, which are independent events. That's why the probability of A intersection B, how do you calculate? You calculate it by writing what? Probability of A into probability of B. Now substitute the values. P of A is 0.4 plus 0.5 minus 0.4 into 0.5, which will become 0.2. So this is 0.9 minus 0.2, which is 0.7. That is the probability that student will solve at least one question or at least one of the two questions is 0.7, option B. Alright, coming on to the next question, 105. Here you know that x bar is the mean of these observations x1 to xn, and xi is defined by this relation where you can see there is a connection between x and y variables. Means x1 you can write it as a plus c into y1. Means what is y1 from this? It's x1 minus a upon c. So following this rule, you can write down until yn, which will be xn minus a by c, isn't it so? Now why I did it so? Because they are demanding you here the mean of these variables, and the variables y1 to yn are of this type. Okay, so means I have to find out the mean of these observations. So you know the mean formula, sum of the observations divided by number of observations. So when you are finding the y bar, that is the mean of y observations, this is the sum of the all these observations I am going to add. There you see that x1 minus a by c, I will going to add until xn minus a by c, the whole divided by n. Now what is happening in this? You see that the denominator c is common number, constant c. Okay, and x1, x2, x3, so on, xn, they are added. So what we can do is, we can put this 1 by c outside, okay, and the numerator part, x1 plus so on till xn divided by n, then minus a, how many times? N times. Hai na? This will be n times upon n. So you can see that this one, this first term reduced to what? X bar, and the numerator is n times a upon n, which will give you just a. So basically this is equals to what you got, 1 by c x bar minus a. 1 by c times x bar minus a, which is same to say that x bar minus a divided by c, and that is the mean y bar. So it's the option D. Alright, coming on to the next question, 106. Here this is the theory question. You can see there they talked about the correlation coefficient. You may now here clearly know, if you have gone through the theory part of this regression analysis, whenever rxy, the coefficient, correlation coefficient would be 0, you know that there will be no relation between the two lines, and the two lines are actually said to be perpendicular hence. But here they are saying that the lines are parallel, which makes the statement incorrect. And when actually the correlation coefficient is plus 1, means they are both the types, like they are following the relation, like if one line is in increasing nature, the other is increasing. So when rxy is equals to 1, it specifies that actually lines are parallel. Okay, parallel and following in the same direction of change. So here they said perpendicular, this also the wrong statement. Hence neither one nor two are the correct statements for this particular question. Alright, coming on to 107th question. Here there are two equations, which are the equations of two regression lines. You want x bar, y bar in them. So how do? You will replace x variable by x bar, y variable by y bar, and set up the equations. This is equation number 1. Then 20 x bar minus 9 y bar is equals to 107, equation number 2. Now you have to handle this by elimination process. If you multiply this by 5, the first one, what do you going to get? 20 is getting cancelled, right? Minus, plus, minus. So x bar is getting cancelled. When you multiply here with y bar, here it is minus 25 plus 9 times the y bar. And the right side here also you are multiplying, right? 5. So this is 5 3s are 15, 5 3s are 15 plus 1 16, minus 165 minus 107. So how much you get? Minus 16 y bar is equals to this addition going to be 12, then this 7 and 272. Isn't it so? Minus. So minus minus is anyway getting cancelled. You can reduce this number even further. This is 2 8, 2 1, 2 3, 2 6. Isn't it? Then 8 1, 8 1, then remains 8 7s are. Isn't it? 17. Y bar is 17. It is given in the option C. So I'll go with C, but I would like to check value of x also for you. So you pick up the first equation to calculate the value of x by putting y there. So 4x minus 17 times 5. 17 5s are. Okay, how much you will get? 5 plus 85. Okay, 85 plus 33 is equals to 0. You can see that 4x bar is equals to, actually this difference is going to be 2 minus, okay, minus 52, which becomes plus 52 on RHS, and x bar is going to be 4143, 13. See, I have checked that for you. Okay, so option C is the right choice. Now, coming on to the question number 8. See, question number 8 is again a basic, basic theory question where you should know about the terms change in scale and change in origin. If you don't know, I have made a special video so-called statistics hacks, and I am going to attach the link of that video at the end of this session. So you can click on the link and follow that video for knowing what is change in scale and change in origin means. See, basically change in scale, I am simply saying you here that when you have an observation x1, and when the x1 observation is changed by multiplying either by k or dividing it by k, like that, then means you are going to change the scale of that observation. So when you basically change each observation by scale, like make it each observation changed by k times the observation, then the mean also going to be changed. Here they are saying that mean is independent of change. Means, what does it mean? Independent means mean remains the same if you change the scale also. That is what they mean. But it's not. When you change the observation by making it the scale change, I mean when you change observation x1 to kx1, the mean also will become k times the original mean. And the change of origin means here each observation you are either adding it by certain k or subtracting it by certain k. That is called change of origin. So when you do the change in origin also, the mean accordingly, if you do plus k into each observation, mean will be plus k times. And when you do minus k times. So it will be changed. It means it is dependent. Mean is dependent on change in scale and change in origin. But what they say here, independent. That's make this statement is incorrect. Isn't it so? This statement is incorrect. So statement number 1 is wrong. Even the statement number 2, if you see, they say variance is independent of change in scale, but not in origin. They said actually opposite. Actually, variance is independent of origin, because why? You know the variance formula. It is positive square root of, you take sum of xi minus x bar the whole square divided by n. Isn't it? The basic formula I am considering. So basically here you are doing the subtraction. Isn't it so? So if you do the change of xi as xi plus k, x bar also plus k, so that gets cancelled, and it doesn't change the value of this square of this deviation. So hence the variance remains the same if you change the origin. So it is independent of the origin but not of the scale. Okay, that's why this statement they oppositely meant here that it is independent of change in scale but not in origin. This is also a wrong statement. Hence neither one nor two are correct statements for this particular question. Alright, coming on to the next question, 109. Here you see again a question on the basic concept. Sum of the deviations from mean is always 0. Yes, you know when you have your observations, any, say 1, 2, 3. Okay, now you take the middle observation or calculate the mean of the data. Whenever you calculate the deviation with respect to the mean, what is the mean of the data? You know it's a 3 plus 3, 6 by 3, 2. So xi minus 2 going to be here minus 1, 0. and 1. You see sum of the deviations about the mean too for this particular data is 0. In fact, it will be 0. Sum of the deviations from mean for any data is always 0. So statement 1 is correct. But what about statement 2? The sum of the absolute deviations is minimum when taken around median? Correct. So whenever you have a median, like you see here, the median is, for this particular data, the median is, the 2. And mean is, in fact, we are getting the same. So when median and mean same, okay, it behaves the same. But when you have other observations, suppose you take now 4, then median becomes around the average of 2 and 3, which is, 5 by 2, which is 2.5. Now when you pick up the 2.5 and go on, calculate the deviations, no, 1 minus 2.5 minus 1.5, 2 minus 2.5 minus 0.5, 3 minus 2.5, it will be 0.5 and then 1.5, isn't it so? Now this sum of the absolute deviation, when you take, absolute means sum of the absolute values of these deviations, when you take, this value going to be always a minimum, comparing to the mean. So you can verify this for the data, and hence both these statements here, okay, they are correct statements. So both 1 and 2 are true for this particular question. Now question number 110, here you see there are the data values given to us. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 done, and this 2. 12 observation. If you put them in ascending order, the negative value minus 4.8, then 0. Then after that it follows 2.3. Then what you will say? 3.5 we have, 3.9 we have, 3.5, 3.9 we have. Then there will be next what follows? 4.6, 4.8. Then after 4.8, what it follows is that 4.8 was minus, right? So I would not take this. 4.6, after that you will have 5.2. 5.2 is there. 5.2 is there. Then 6.1 you can take up, isn't it? 6.1 you can take up. Then you have 7.6. Okay, 7.6. Next in a line. Then you have 8.2 in a line in ascending order. Then you have 9.3. Okay, 9.3, and then you have 12.7, isn't it so? 2.3 already have taken, minus 4.8 taken, 4.6 taken, 3.9 taken, 3.5 taken, all have taken now. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 observations you see. There are 2 middle observations. Okay, if you split now, you see there are like, we have around 5 and 5 kept around. So this 5 here and this 1, 2, 3, 4, 5 here. So remains is this 2. So the median will be the average of these 2 data values, which are the middlemost observation. 4.6 plus 5.2 divided by 2. What do you get the average of this 2? It's 8 and this 9. 9.8 by 2, which will be 4.9, which is the option number C, B for this particular question. Hopefully the solutions are clear to you. Please stay tuned with my channel. I'll be keep coming with the previous year's questions fully solved, simply solved for you for NDA previous year's papers. All the very best for your preparation. Keep following my channel.